Hello. This morning I'm starting another production job. It's shafts. I have to make 20 of these. This is the drawing. It's made out of 1.25" diameter turned, ground and polished 1045 shaft material. And I have to, it's not a really difficult job, but I have to cut the length, face, chamfer the ends. And I have to ream a hole in the end for a 6mm dowel pin, which I then have to press into a certain depth. So I have to make a little sort of a thick washer there as a stop, so I get these in the same, all of them exactly the same distance. And then I have to go in and make a couple of dimples. You can see right here. And this shaft is actually the video I made a while ago about production machining bushings. This is the shaft that fits inside of those two bushings, and if you remember, there was a 3/8 set screw in the bushing, and that 3/8 set screw is going to bottom out in this dimple and hold the shaft in position. The first step is just to set up my saw, which I've already done with a stop, and saw these about 3/16 of an inch longer than they need to be, than the finished length, and then I'll put them in the lathe and I'll face each end, and then I'm going to put a stop in the spindle of the lathe so I can just insert the one finished end and face the other end right to length. When you have this many to do, it speeds it up quite a bit when you can do that. This is my setup on the saw for cutting these to length. And although this saw is, I think, made in Taiwan and everything on it is metric, the one thing that's imperial is the rod they use for the material stop. It's 5/8, which has come in handy because the original one wasn't long enough. So I just took a piece of 5/8 material and extended it. At this end, I'm using my scissor lift table as a rest because the parts are long and it's too hard to balance them on the saw. The saw is pretty narrow. I bought one of these scissor lift tables and started using it in my shop. And these have, well, they were so handy I bought a second one. But I have to say that these are probably one of the handiest tools I have in my shop, is a scissor lift table. It's amazing all the things you find for them to do. With this production work I've been doing lately, I can just load all the parts on and bring it up close to the machine, and then I can take one part off, machine it and put it back on, and then I can wheel it over to the next machine for the second operation. Handy for that. When we built my overhead crane last summer, we used it for moving the bridge beam around on the floor. Worked really well for that. And I've also sort of turned it into my mobile grinding stand because I had a lot of deburring to do with all these production parts I've been doing. So the nice thing about this was you can raise it and lower it and set the belt at whatever height makes sense. Sometimes you want to deburr in the middle of the belt. That's where I do most of my deburring. And sometimes it's handy to be able to just do it on the bottom of the wheel for certain things. And being able to raise it and lower it really saves your back when you have a lot of parts to do. This is a bit of an oddball setup. We had a whole bunch of welding to do where the parts were all laser cut out, and it was the parts were located together with tabs and slots. I'm not sure how many people may have seen that before, but it's kind of a new way of, I don't know how new it is, but new to me, way of positioning parts together before you weld them, and it works quite well. But one of the problems is the tabs weren't being undercut, and there's a little radius at the bottom of the tab. There's a radius there. Now when we go to put that in the mating part, which has a slot in it that it'll drop over here, it hits this radius and it won't sit tight to this surface. And we had hundreds of these tabs like this. And what we ended up doing was we took this chop saw, which has a pretty nice narrow blade on it, and I scabbed this thing together. It's sort of half-assed, but it works pretty good. And then you get it going. You have to tape the switch and then just turn it on and off by plugging it in. But when you get it going, then you can just feed in at 45. And I'm not going to do it, but you can see how it would work. And it undercuts and does a really nice job. So anyways, the reason this cart was set up like this was because I had to both undercut slots and deburr them. So I set both the belt sander and our undercutting saw up on the same cart, and then when I went to undercut, I could lower the cart so it was at the right height, and when I went to deburr, I could raise it up so it was at the right height. Anyways, these scissor lift carts are just endlessly useful. If we look here, the shaft is touching the saw on that side. If we look on this side, I don't know if that's going to show up, but there's light under, meaning the shaft is sitting like this. What we can do to fix that is we can just raise the cart up. And now the light's disappeared. And it hasn't appeared on this side. So now we're sitting level and we'll get a square cut. Again, another feature of these scissor lift carts that makes them so handy. This is a modification I made to the jaws on the vise on the saw. I did this shortly after I got it. You can see the jaws only come to here, and the blade is about here. So it makes it so you can't cut really short items. So I got some cold rolled steel and I just extended them out almost to where they're touching the blade. So now you can put short items in and clamp them. It also helps when you angle this vise, because when you angle it, no, that's not right. You have to take them off when you angle the vise. Never mind. Works good for cutting short items straight. You can see how with the old setup I never could have done this cut, yet with these jaw extensions I'm pretty confident making that cut without much hanging out. And there they are. Or not quite. I actually got shorted on the material. There's only enough for 18. So I have to go in later today and get another piece of material to make the last two. The first part here, just facing the first end, is really basic work. It's barely worth showing, but I just come in and touch off, zero the readout, go over about 30 thou. Roughly, it doesn't really matter. Take the cut. And that was done at 950 RPM. And I'll drop that down to 230 to do the chamfer because I'm using high-speed steel. And for the chamfer, I put about a 25 thou chamfer, so it's not, again, it's not critical. I just come in and touch, zero the readout, and then I just move along until I'm at about 25 thou. Just feeding by hand. There. See the readouts at 25. So pretty basic work, but made easier by having digital readouts. Now there's all 18 have been faced on one end, and now I have to go to town and get the rest of the material for the last two that were missing. I got the extra material I needed, and I now have 20 shafts that are cut a little bit longer than they need to be, and one end of them has been faced and chamfered. And now I need to set stop up in my lathe so I can face the other end to length. In my lathe, at the back of the spindle, this lathe came with a thread. I can't remember what size it is. But I believe with this lathe you could buy an optional collet closer and it would thread in here. I never did buy the collet closer, but I did shortly after I got the lathe. I did machine this piece here, and this thread mates with the spindle. And then I have a hole through the center, a threaded hole for a long rod, and then this is a support that just keeps it from flopping around inside the spindle. And with nuts on either side, I can move the support around, and of course I can move the rod around inside this end piece. And then I just have this I use as a jam nut. Now, when I first built this, I had a 7/8, or I can't remember, it might have been a 3/4 inch fine thread, and it was okay, except the thread was so fine that it took forever to adjust the length if you had to change the length quite a bit. And so in order to save this piece and reuse it, I had to go to a 1-inch. It was the next largest size where I could drill the old threads out completely and cut new ones. So I did that. The only downside is that when I put this jam nut up against the end, I cover over the holes in the end, which were there for this wrench, which I had made at the same time. And that wrench was there to, it used to slip over the 3/4 inch threaded rod, and the jam nut would fit in there. And then those two dowel pins would fit in these holes, and I could tighten that up in the end. So now I just have to remove this whenever I want to tighten that in the end. So, how do you use this? Is I'll put the part in roughly where I would like it when I'm going to machine it. Now I know I'm only taking about 1/8 of an inch off, so I can put it about here's probably about right. Take this off so I can get the wrench on. And I need to tighten that in. I'll just see how far in we have to go. Okay, this is going to stick out a long ways. This is where it used to take forever with the fine thread. It's much quicker with this coarse thread. There. Now that part's threading into the spindle. There. Now that's locked to the spindle. And then we can just advance this until we hit the back end of the part. There. Okay, now I spin this on. There, now that's locked in. And the next thing I do, whenever I have something like that sticking out of the spindle, so I keep these 3 pails here. I like to put the pails in the way because it prevents you from walking into the end of it, which would be bad news if it's rotating. Even if it's not as bad news, but it could get really bad if it was. Now what I like to do, whenever I set a stop like that, I was setting it up against this part which is stuck in the chuck. But from now on, all the parts I do are going to be inserted in until they hit the stop. So I always like to, on the first one, release it and just insert it back in the way all the rest of them will. Now these shafts, when finished, are supposed to be 15.5 inches long, and my biggest pair of dial calipers goes up to 12, so that's no help. I do have a pair of 24-inch vernier calipers, but I don't have anything in between, so I have to use the vernier calipers, and these are them. I bought these new probably about 16 or 17 years ago, and they didn't come in a box. So I made the box myself out of some hardwood. I'm not even sure what kind it was. And I milled out the grooves to fit the caliper in, not with a router like you'd think, but with my Bridgeport clone milling machine, because I didn't own a router at the time. Anyways, it's turned out pretty good, and these have proven pretty handy. So we're at 15.6. I'd say 611. I don't know, I struggle to see this now. 15 years ago I could read this a lot easier. Might be 15.610. The length doesn't have to be that accurate. I'm gonna go 15.610. So I know that when I machined this originally, I'd set the readout to 0, and I'll just confirm that. That's pretty close, it's within 2/10, and I have to take 110 off, so it's gonna move into 110, 0 the readout, and now I'll machine this to this length. That should be 15.5 inches, and now I should be able to just I may have to take these in 2 passes. I may not be able to leave the tool exactly where it is, but for the final pass, final facing pass on each part, I will put it where the readout is 0, and they should all come out the same length. So for this, I'm going to actually leave about 30 thou for a final pass. That looks pretty good to me. Close enough for this job. Now it should just be a simple matter of putting the finished end in from all these until they bottom out. trick here now is to resist the urge to reset the y-axis to 0 for doing the chamfer. That would change the setup for the length, so you just have to make sure you avoid doing that and just you know, count the 25th thou off the readout. And repeat 18 more times.